Hey everyone, this is our lesson on gas properties, and by the end of this lesson, you should be able to explain the relationship among pressure, temperature, volume, and quantity of gas, both qualitative and quantitative. We're going to really look at just qualitative today, knowing the relationships that you need to know. Before you get started though, you may want to pause here and review gases and kinetic molecular theory. So let's just go over some basic properties of gases that are important for this lesson. Remember that gases can adjust to fit in any container because they have indefinite shape and indefinite volume. So the amount of gas it takes to fill up an entire house can also be squeezed into a 4 by 4 inch box. 4 by 4 by 4, I guess. And then this is all due to the property called compressibility. And that means that it can fit to fill any container that it's in. So it can be compressed down to fill a very small container. It can be allowed to spread to fill up a huge container. Remember, with gases, the volume of the gas particle itself is much smaller than the volume of the gas sample. So there's a lot of space around these particles, and that space is what allows you to be able to push them together. So one good comparison I used to hear is if you took a gas particle and you compared it to the size of like a ball bearing, not too big, about this big, then the space around that gas would be big enough to fill up a football field. And that's just like a macroscopic comparison. Remember that gases also hit in perfectly elastic collisions. So when they run into each other, there is no loss of energy or gain of energy. Okay, in terms of like just loss to the environment, or they gain anything from the environment. They should be moving with the same speed before and after, so there is no net change in energy. And then remember that the kinetic energy, which is the energy of motion, is directly proportional to the Kelvin temperature. As you increase the temperature, the particles will move faster. So there are some variables to understand that affect gases, which we will use in the next two lessons where we learn about our gas laws. So the first one is pressure, which is noted by the letter P, capital P. And this is the force exerted by a gas via collisions. So that could be collisions with other gas particles, collisions with the container that it's in, collisions with just things in the environment. And that would be actually what's called atmospheric pressure. So this is collisions between gas particles and objects like outside. Sidewalk, buildings, trees, humans, whatever, will build your atmospheric pressure. The units for pressure, this is the only one you have to deal with a lot of units on, and that's kilopascals, millimeters of mercury, torr, and atmospheres. The next is temperature, which is noted by the letter capital T. And this is the amount of kinetic energy that a gas particle has. And our unit here is Kelvin. If you are in degrees Celsius, you will have to switch it to Kelvin. That is important. You have to know that from the get-go. For volume, we note this by capital V. And this is the amount of space a gas takes up. And our unit here is liters. So if I give you milliliters, you've got to change it to liters. These are not negotiable. Temperature has to be in Kelvin. Volume has to be in liters. For pressure, you can pick a unit. Okay, so it just depends, again, whenever we're looking at our gas laws, which we'll go into later. You can be you have a little bit of freedom there with the pressure unit. And then number of moles, which is N, lowercase n, and that's the amount of particles in a sample. So how concentrated is that sample? And we would just use our unit here as moles.